Well, Chris, thank you so much for hopping on the Silicon Fox podcast.
Great. Pleasure to be here, Mitchell.
I always like to start these with just giving you the chance to tell us a little bit about you, where you're working today. Obviously, we have that big DARPA logo in the background, but what is DARPA? Who are you? And just give us the quick lowdown before we get started here.
Yeah, a pleasure. So first and foremost, I'm an engineer. I've come from the academic setting. So I did a PhD. I ran a lab at Carnegie Mellon for about 15 years. And then about 3 years ago, I made the move here to become a program manager at the Defense Advanced Research Projects Agency, or DARPA for short. And in my responsibilities as a program manager, I essentially try to search the technical landscape and identify important problem sets that are relevant to the military. And then also similarly identify interesting new technologies that can be brought to bear to solve those important problem sets. And so it's really kind of essentially a product market fit exercise, you could argue, in some ways, where we try to see where there's interesting opportunities and then find solutions. And so again, also as a program manager, I work with performers. So these can be essentially institutions from academia, small companies, defense industrial base, to come up with those creative solutions that we could then deploy to help our warfighters.
And your lab work was focused on what? What was kind of the background from the engineering side?
Yeah, that's right. So in terms of the technical areas specifically, I'm a material scientist by training, and my academic research was really trying to ask the question: Are there new materials that we can use and deploy to essentially interface with excitable tissue to understand the function of that tissue and maybe intervene as well? So so the simplest and most prominent example of this is going to be neural interfaces, right? So this is a decades old field that essentially tries to develop new kinds of devices, kind of from a med tech standpoint, usually, and sensors and things like that that can eavesdrop on the activity of neurons and other excitable tissue in the body and try to either understand what's going on or possibly intervene therapeutically to sort of alter the function to improve things like regeneration or neuromuscular function more broadly. So it's a pretty broad space. And then again, lots of ways to contribute to this really broad field. I myself was thinking about new materials to essentially use for this application. And so just maybe riffing on that a little more, the classic challenge with neural interfaces is you have tissues, for example, like the brain, right? They're soft, they're squishy, they're round, they're wet. It's all the exact opposite characteristics of things like silicon devices, right? That are rigid, right, dry, inflexible, right? And so how do you kind of harmonize the squishy, noisy, wet world of neurons and other excitable tissue with the sort of the dry, pristine environment of silicon micro devices?
What was the solution? What was kind of some of the breakthroughs that you guys had in the
Yeah,
lab, and what was the
yeah,
unlock there?
exactly. So I think we've contributed and others more so I think in the field, but it's thinking about the idea of transduction, right? So one of the classic challenges is that you have signals in neurons, right, and they are represented as voltages, right? So you think, okay, that's great, but those are almost always ions that are being pushed around because they're bigger spatially, right? Tissues and cells can interact with those in a more meaningful way, right? But all the devices that we work on, right, your cell phone, your laptop, those are all basically holes and electrons, right? So a much different, like entity and with different length scales and different properties. So the trick is designing materials that can be able to sort of convert the ionic signals that are happening in the tissue with these sort of like electronic signals that are happening kind of in those more synthetic human-made devices. And so that's I think an important sort of
Well,
finding that's been elaborated on by others.
yeah, have there been like materials that have succeeded at that? What were they, and like I guess what was the process of finding them?
Yeah,
Slash, like, are there applications of it today where there's a use for that
yeah,
convert? Obviously, I can think of a lot, but like, is there something being deployed that's using that convergence?
yeah. This is a great question. So the answer is yes, and then I think the classic material class that is used in this instantiation is conducting polymers. And so these are essentially materials that can conduct both ions and electrons for more or less equal proficiency. And so you could now see that that is a good sort of, you know, intermediate layer between going from, let's say, neurons that are firing versus the recorded signal in your device, right? And so there's a good way to sort of reduce the impedance, reduce the resistance across that interface. And it turns out conducting polymers are a good way to do that. And of course, there's tricks you can play with the structure and the chemistry, but it's all kind of directed at reducing that mismatch between those two realms. And so, for example, you can imagine having, a neural, classic neural interface that's maybe has a metal electrode that now has this conducting polymer coating on it that can essentially reduce the impedance, the effective impedance between that device and that cell or tissue, right? So that's a classic application of that interesting new material class in as it pertains to neural interfaces.
Gotcha. Very cool. I mean, I assume then there's like a lot of research across different institutions. Is this something that DARPA has touched before, or is this more coming from academia alone? What has been the macro landscape of some of what you work on?
Right. So just full disclosure. So this is not something I work on in my capacity at DARPA right now. But
Yeah.
interestingly, I was actually a performer on a program that looked at this. So we were essentially trying to understand new materials and the reactions of tissue to those conducting polymers to understand not only their initial properties, but how their properties evolve once they become implanted. So that's and that's been a contribution. That kind of builds upon several active programs that have been done historically through DARPA. But again,
Fascinating.
not my current focus uh, at DARPA right now.
Yeah, no, super fair. I mean, fascinating stuff. So I want to shift to DARPA a little bit, and understand both the DARPA process, the DARPA mission, and getting kind of into the details here as to the value add, how this plays into geopolitics and so forth. You gave us a really brief description of DARPA, but maybe going a little bit deeper, like beyond the just what is DARPA, what are some of the types of projects DARPA works on? Why was it initiated? How does it keep staying in line with that goal? Do you think we're doing a good job? I'm sure, obviously, internally,
Right.
yes, but like, just give us some of those frameworks before we jump into deeper
Yep.
stuff within DARPA,
Yep. So I can start kind of high level, then and I'll let you kind of dictate and ask questions. But
please.
at a high level, essentially DARPA was created to sort of um, create and prevent strategic surprise, right? And so this kind of has its instantiations in the with the launch of Sputnik, right? And there was basically a decree that we should never be surprised by an adversary ever again. And so really the at the time the Advanced Research Projects Agency ARPA was stood up to try to prevent that from happening again, right? And so in its current form, right, the Defense Advanced Research Project Agency DARPA has that same mission, right? So we're trying to create and prevent surprise. And so what that means necessarily is that we often operate at the frontier of human knowledge, right? And so I could speak to the programs in my portfolio, right, primarily, but in my programs we are often doing very foundational research, right? We're kind of in lockstep with the scientists. We look at the same problems together, and we work with, again, very fundamental research programs to try to understand the frontier of knowledge. And then by doing so, then we are also necessarily understanding what's possible and what's not possible at any given time. And another important characteristic of DARPA that I think differentiates it from other kind of funding agencies is that we recognize that frontier is always moving, right? There's new knowledge that gets created either in the domain or some other adjacent domain. And that dynamic knowledge kind of landscape can really lead to, the idea of, expanding programs or maybe even shutting down programs, right? So it's a very dynamic essentially again landscape that we're trying to navigate to understand what the frontier is at all times, right? And so I think another highly differentiating characteristic here is instead of other foundational research sort of entities, right? For example, like the NSF or the NIH, it's like their remit is thinking about creating knowledge first and foremost, right? But ours is kind of understanding what the frontier of knowledge is. So you can kind of see that they maybe
Wow.
rhyme in some ways, um, but they're very different in other ways. Another thing is again is our mission, right? So we are nested under the Department of War, and so that is our that's our ultimate stakeholder is the Department of War, right? And so thinking about that, right? A lot of our programs, and all of our programs have some kind of DOW related kind of flavor to it, right? We have to ask the question, why is that relevant for the DOW? And that's something that we take very seriously.
What does the national security mandate kind of change about project selection here and understanding what to find? Because I guess what the first caveat that seems to arise is trying to find at the frontier. We never want to be surprised again. There are still instances where we do get surprised. Like how often is it a lagging versus leading project where we are discovering something new, or we're saying, oh, oh wow, we're behind X and Y Z in this domain. And especially like in today's landscape of geopolitics, like how does that fluctuate? Where we look, what we look, is it really defense first? We do things, and DARPA does things that we'll talk about in biopharma and biotech and these kinds of spaces. Obviously, there's a lot of convergence here, but how do you guys think about that balance, especially kind of in some of the mandates today and geopolitics today and so forth?
Yeah, so my remit is mainly as a scientist. Again, I'm an engineer first, and so I think more about the technology sets. I think we, rely on other partners to give us the different swim lanes and things like that of what to focus on, right? So again, my day to day is really about the science and the engineering. I think very seldomly about some of those broader issues, frankly. So
Yeah.
and I think maybe one thing I can kind of talk about in terms of the science is the good news is that science is very hard, right? So even if um when we think about new projects, there's nothing really magical about when if we write a check versus someone else, right? It's like the science is always very hard, and so things kind of creep along. Uh, you know, it's some ways very slow, in some ways very fast, right? So I think just understanding where the most dynamic elements of the knowledge interface are, I think that's a really important thing that I think that we're good at. So we can kind of understand where the velocities are different or interesting, and that's I think where we commit a lot of our resources. And maybe one thing to foot stomp here is that DARPA as an agency is not it's not particularly large, right? We have about I'm a program manager. There's about roughly 100 people like me in a building, right? We don't have any physical assets. We think of important problems, and then we commit resources to understanding and solving those problems, right? So to that ends, right, the programs are end up being fairly targeted, right? It's again a very different remit than the NSF, right, which is thinking about more broadly about science, right, and just creating human knowledge. And that's gigantic, right, in terms of its mission. And or the NIH of improving human health, right? That's a gigantic mission. Our investments tend to be more focused and targeted in kind of key areas. Again, maybe key areas that are of interest to our stakeholders at the DOW and others, or maybe are particularly dynamic in space and time.
How do you okay, so maybe more on like the science part of that. How do you think about dynamic components? Because I guess if we're discovering frontier things, within DARPA, in America, if somebody else has discovered, X, Y, and Z thing, is the objective to, find the path of least resistance and see if we can take a path around that in a faster, more efficient way, potentially more scientifically superior? Is then the goal to say, oh wow, we need to keep up here and mimic what's being done and potentially build on existing research? Like, how do you guys mitigate that component from a scientific perspective? Because I can envision it gets pretty complicated and broad. And in fact, I'd actually love to hear about the process of project selection. Because if
Mhm.
you just think about like, hey, what's every problem that exists in the DOW and how can we use science to solve it? There's so many things that we could probably bring up and spin up, and some that push the boundaries of physics and some that don't, and that's obviously a hard trade off.
Yeah, that's a good question. And so I think one part of that process, we could talk more about the process later, but I think the interesting thing about the process is that our stakeholders are pretty clear, right? So we sit under the DOW, and so we engage with our partners from the different branches of the military, and so we have active conversations and relationships that we build over time with all those stakeholders. And so I think what happens, at least from my standpoint as a program manager, is maybe you keep seeing the same problem come up again, up and up again, in the same, maybe two or three times in different conversations or across branches, or maybe there's something particular about a certain um need that everybody has, then that's a good healthy demand signal that then says, okay, well, that suggests we should maybe make an investment here collectively, right? Because we serve all the branches, right? So maybe there's something here we should look into, and then we then map that to existing technology vectors. So maybe that's an important problem set, but guess what? We don't have the knowledge yet to really um, move the needle here. And in that sense, even though we're doing fundamental research, we are mission driven. We have an applied kind of theme that can kind of come through in a lot of our programs as well. Where it's not just curiosity driven research, right? It's fundamental research that's with a specific mission in place. So classically speaking, this is occupying kind of pastor's quadrant, right? Just kind of fundamental research, but with a real with a clear kind of like need that we're solving.
How often, kind of still on the same topic, to try to understand like the balance, I guess, what's between projects. How often is it that whatever you're able to share on this, like that a project doesn't come from a problem, but comes from a competitive edge?
Mhm.
Maybe I'm missing something and this is not an edge case and it's always aligned, but maybe someone's developing something. We see some paper come out of a different country that says something really frontier could be done in biodefense or something bioweapons. And we haven't noticed that there's a problem because it's kind of a proactive, like it's a weapon rather than, hey, we're solving this problem. Like defense first versus war first, right? Even like some of the recent macro changes, Department of Defense, Department of War, like thinking through that, how proactive are we about, you know, finding frontier science to develop things that we know are going to be useful or have strong hunches, or we've seen being done elsewhere, rather than starting from problem first and saying, okay, a lot of branches are having an issue. Let's find the most efficient way to solve this via DARPA. Like, is there a trade off between those two? Are they constantly aligned? And if not, like in the latter version, what does that look like? Are we constantly seeking, different papers and saying like what's going on in the world and then turning that into science or building on the science? Like, what does that landscape look like?
Yeah, so I would interesting question. So I would go back to just preventing surprise, right? We just don't really want to be surprised with things, and so in that end, a lot of the research ends up being, again, like I was saying before, just kind of on the frontier of knowledge, right? So
Got it.
and that's very foundational. So so again, it's of course there's the threat landscapes are always evolving, right? That's true of any organization, right? So, and so I
Yeah.
think it's kind of the same with us. So we so we interact with our partners and our stakeholders, and we just try to understand their needs. And for me personally, I think that's the most important thing, because what if we're thinking about programs, right? A success of a DARPA program is that someone sort of takes it on, right, and that it becomes transition to someone else. And so, at least where I stand, I work with partners that have a vested interest in the success of the program, because then they would be the one that could then, take the knowledge, take the success, and then kind of like bring it forward to ultimately help our service members.
Gotcha. Yeah, no, I mean, that's super fair. Do, one thing I can envision that's probably complex is like they're having a lot of stakeholders. I mean, this is like the common complexity of startups and
Yep.
frontier innovation companies, taking all these stakeholders, building it into the right thing, and especially because there's maybe the feedback loop is optimized, but how do you think of the development production pipeline? Do you think it's effective? How do you optimize it such that it's effective and that good science is being done rather than getting lost in the ideation phase?
Yeah, that's right. So I think it's all about feedback loops, and you hit on it yourself. So I think feedback loops in all parts of the process. And so again, if I think about basically a program, you can think about it, spinning up a new program, the phase that you're in, and then kind of our transition when the program's concluded, like what happens to it. So I think again, feedback at all the stages is really important. And so maybe focusing more on the actual like period of performance of the program, I think that's a good time to think about, um, like maybe there's interesting new discoveries that either in or outside the program can alter the course of that program. Maybe the program starts with some assumptions that turns out actually no, those assumptions end up to be either wrong or incomplete, or there's a lot more assumptions that or the impact of those assumptions is even bigger than we thought. So we should double down and expand the program, right? So I think having, again, embracing the dynamism is a really important part of that process, and that's something that we're that we embraced, right? So it's in terms of working with our performers, working with our stakeholders, vectoring the focus to to ultimately again serve the service member. I think that's really that's kind of in the DNA of myself, and I would say many of the program managers that work at the agency.
Were a lot of these processes built for optimization, or were they kind of built risk adjusted for not keeping in tenure too long? Like having a lot of stakeholders, then also having short term, or shorter term, a few year PM stints, and then developing work that maybe takes 10 years to develop across different PMs and so forth. How is that all mitigated? Like, how is this process built? And then how do you think it's playing out today within DARPA? Because I assume some of these challenges and problem sets take, years to develop, and whether objectives change, geopolitics changes, ideas change, new science arises, PMs change, et cetera. It's probably a lot of factors to mitigate.
Right. So yeah, it ends up being a pretty high dimensional kind of problem set here, right? So I think one thing about the stakeholders is that even though there are many different stakeholders, oftentimes you probably you'd agree, right? The really you just need the right stakeholder, right? You need the right champion with the right problem set that they want solved, where they're willing to commit resources to solve their problem. Because not unlike customer discovery, right? Find your customer first, right? So even though the DOW is gigantic and there's many possible stakeholders, I really focus on the right stakeholders, right? Because they're the ones that are gonna commit resources in the next phase of the program. So and in terms of some of the other, again, the sort of dynamic components here, I think one thing is uh, that there's different technology readiness levels, right? So, I work in the biological technologies office, right? So, our work tends to be very foundational. Just that's just the nature of our work and what we do. Um, but we absolutely have other offices that work on different TRLs, right? And so I think that where you're kind of operating there is really kind of informs how like what we want to get out of a program. So for example, for me, it might be that if I think there's a new area that's interesting to maybe plant the flag in the new area and leverage some of the convening power of the agency with resources, of course, right? Bring people around together and create a community that could then be self-sustaining. Maybe there's a follow-on NIH effort or some other effort that could be catalyzed by that initial DARPA investment. So that's one form of transition, right? And then other transitions, it might be, again, maybe it's not our office, maybe it's some other office, but maybe it's, they make a widget and then they sell the widget to a stakeholder that needs that widget. And that stakeholder buys, a lot of those widgets, and they are happy and we are happy because we've then transitioned the technology successfully into sort of an internal stakeholder, right? Either of those or anywhere in between, I think, are examples of how we think about the endpoint of a program. It's not just about coming out of the gate and having a cool idea and a cool program and just kind of just going into it without first thinking about what's the endpoint going to be and what that looks like. And so, to the best that we can, of course. Again, that's another reason why we think about the dynamic environments and the different contours that science and technology can kind of different surprises that science and technology can show us along the way.
Are you a health coach or running a health course and looking to level up your client's experience? With Cyfox Health at-home blood test, you can deliver lab-quality blood work right to your client's door. Seamlessly ship samples back for fast and actionable results. Personalize every consult with the data that matters. Clients who complete a Cyfox test are 60% more likely to enroll in a paid program after their consult compared to those who only join a sales call. If you're ready to give your clients the edge, go to cyfoxhealth.com/partner. And as a Silicon Fox podcast listener, enjoy 10% off your first bulk order. How do you guys think through existing breakthroughs and building on top of them and taking them across phases, whether it's CRISPR or different types of technologies that have been developed? How do you think about building on top or pushing along phases, getting to functionality? Like, what is the real difference? Like, phase one is maybe foundational, phase four is deployment. Like, walk me maybe through that process a little bit, through discovery to actual deployment, and maybe some cool examples of technologies that have gone through that full process. Because it seems like often a lot of them get held up in certain places for subset of reasons, often good ones, but maybe more like on the success story front of it, whether building off on top of things, maybe discovered internally at DARPA. what does that process look like, and what were some of those technologies?
Yeah, yeah, excellent question. So, I mean, I would kind of lump all those examples that you cited as sort of enabling technologies, right? And so that is a part of our internal deliberation process to see if the idea for a program is uh, worthy of being converted into a full program, right? So one of the things that we look for is in our framework, which is called the Heilmeyer questions. We can talk about that later as well. Is one of the key factors is what's new, like what's like essentially why now. What's new? What could be a technology either that is newly discovered organically in that domain, or a capability that exists outside of the domain that can be brought over to a different kind of arena, right? And so those are examples of different kinds of enabling technologies, right? And so a lot of times, again, so we leverage those. So we think about those as essentially de-risking capabilities, right? So, you might, think of a kind of a toy example here about, 3D printing, right? So, it might be that, hey, if you're now able to make arbitrarily complex forms, right, then that can maybe unlock new capabilities for new metamaterials that could improve the sensitivity of biosensors by 100x. And then if you have a improvement in the sensitivity of a biosensor by 100x, that gets you down to a the ability to analyze a biomarker that you weren't able to analyze before, but now you are, right? And then that can unlock maybe an awareness of physiology that was not before seen, right? So you can kind of see that the daisy chain of an initial enabling technology in 3D printing, maybe material science, could then be ported over to a sensing capability that can then lead to a specific technology that's directed at resolving or helping solve an existing kind of problem set.
Yeah, I mean, super fair. How do you think through like this mixture? I guess capital can be found in different places, and maybe DARPA is a lot more strategic. And I know that you're talking here from more of the scientific perspective, but maybe if you've even seen with your own programs on a trade-off or not a trade-off, but like a VC versus DARPA, or maybe it's a cohesive ecosystem. Like thinking about it from an American dynamism perspective and frontier science, like obviously a lot of biotech VCs love frontier science, and when there's a new massive unlock, capital flows. What's the differences here that you look at through DARPA versus VC, and how they kind of play together in the ecosystem, and is it effective in pushing the boundaries of science, or should we
Right.
kind of reframe this from your perspective?
Right. So maybe taking the last one first, we can probably have like a 3 hour discussion of is it effective or not, right? So I think
Yeah,
that's a great question. I think it's the answers I think is you'll get different answers from different people, right? I think it's
yeah.
fairly effective in its current kind of form, right? So maybe back to
Why is
the
that?
yeah, the first part is basically what's the difference. I think it's just timescales, right? So having being able to make investments where the program might be 3, 4, 5 years in itself, that might lead to another program that might lead to a technology that comes out 5 to 10 years later. I think there's just time to think, time to embrace risk, right? That's another important part of of our ethos, right? And maybe it's an opportunity to do something that a VC would not touch, right? Because it's not in that 2 to 5 year kind of return kind of time horizon, right? And so I think that really kind of affords us. We have a unique part of the pipeline, right? Which is basically the earliest of the early stage, right? Again, in the for my programs, like success for me is maybe even a follow on NIH program, right? That may exist for 3, 4, 5 years, right? And so now if we're talking that, then that's maybe another 3 or 4 years to for the discovery, 3 or 4 years to start a company, kick out a product. Now we're talking almost decades, possibly, right? Again, in my specific instance, others it's shorter, right? It depends, but I think having that early stage focus, right, and tolerating high risk is really critical here. And of course, we are ultimately deploying taxpayer resources, so we're very mindful of how we invest. We consider these investments, right? But at the same time, we don't have necessarily a board to answer to, on a quarter by quarter basis, right? And so that allows us to to be mindful about taking the right risks at the right time with time horizons that are just uniquely differentiated from the private sector.
One thing that's actually kind of a prevalent thought for me, and I'm curious how you think about this as you think about program selection or team selection. We have some capital allocators in this podcast that are investing in some of the top frontier biotech companies in the world or some of the biggest funds. And I sometimes ask this question on balancing kind of altruism and capital. And fundamentally, when they're like, look, when my VC hat is on, it's capital first. And so that's kind of an interesting disparity. And what I'm like trying to get at here is like, when you're a VC evaluating a company in the biotech space, like, yes, you want it to work, but you want it to work for the sake of capital returns. And if there's a lot of things around it that can yield capital, then maybe there's like room for leeway. You can have like marginal improvements in science or even no improvements in science, but some unlock that will create capital returns. And I envision for DARPA, it's not the case. You need things to actually work and move the needle. And thus, it's much harder to be like lazier within frameworks. And one of the most common questions, I think people ask or see is thinking through like accreditation or team selection or like all of this stuff is super early stage. And so a lot of it is based on team, maybe the physics of the idea, it's feasible, not feasible, maybe their track record. How do you think about that? Because I envision that because it's more binary of did it work or not, do you want to see a history of it working? You don't want like a young person to will it into existence when they haven't ever done that before. How do you think about that trade-off? Because it seems like the goals are a little bit different. It just hit me as we were talking about this, and I think it's an interesting point.
Yeah. So again, I can speak for myself here. I do think there's a kind of a capital equivalent to me, and that's impacting the warfighters' like life, making their lives better, safer, whatever, right? So I do think about impact in that regard, right? And so
Yeah.
again, if something is not gonna, if A and B, right, and one's clearly gonna have a better impact on the warfighter, I will choose that one over the first one with every decision, right? So I think it's obviously not direct, right? But I think there's an analogy there that I think it's at least how I think about investments, that does kind of inform some of those decisions that I make. Now, in terms of, capital, yeah, I kind of, sorry, do you want to repeat the second part again? I kind of
Yeah.
lost the thread there a little bit. Yeah.
The accreditation component is like,
Oh,
yeah,
yeah.
okay, so let's say that the ROI and how DARPA looks at ROI is actual, um, results of warrior, which by the way, like, is there a feedback loop there? How does that like look like? Is there a time scale or feedback loop that you aim to achieve?
So we think about program successes in terms of transition, and so there's different categories, but there's not really beyond, did you or didn't you? There's not like another real way to quantify that. Um,
Yeah.
at least definitely when the program's running, there's no way to really quantify the success, right? So I think that's a good point. It's a little more abstract, right? But we have a lot of success stories, I think, that we can point to that are almost so big and sort of like so impactful that like it's like, yes, that is like you can look at it objectively and agree, hey, like this is a pretty significant like, hey, gold star, like you did really good on this one, right? So
Right.
and so and so getting there, of course, there's milestones, there's other ways to sort of organize our activities it doesn't, just like end up there, right? So there's a very structured way, and it's very mindful and deliberate how we get there. Phases, milestones. So these are things we measure along the way, and those are more technical metrics, right? But those are ways to measure program success in terms of program impact. That's a lot more nebulous and diffuse, and so I think at least like my goal as a PM is to say, hey, here's something that's so obviously amazing, like you don't even have to bother to calculate its ROI because it's intrinsically amazing and awesome, right? So that's I think an easy way to kind of come over the top there. So and
Yeah,
then
no, that's fair.
yeah, and then on the performer side, of course, again, going back to risk, right? So, again, I can speak for myself. I definitely employ portfolio kind of management strategies when we're looking at performers, right? So it's like, so maybe there's a spread of different technology or solution sets that are being proposed, and maybe you spread those across different TRLs, and you're like, okay, like here's a really kind of like within a program, right? Maybe there's a performer that has a really crazy idea, and you maybe we'll take a chance on that one. And maybe there's another performer that has a more mature, kind of more expected approach, right? But maybe they bring to bear just a really good team, or just like interesting insights beyond that kind of core concept, right? Those are all again calculations that I do with my team, and I'm sure other program managers do as well. 'Cause that's kind of part of how we think about team selection.
Well, my deeper question within that is one that the feedback loop here is kind of interesting, and the outcome of the projects, I guess, are so important because in venture, you can invest in something that doesn't really move the needle for safety, security, healthcare, like infrastructural things, but has capital returns. Here, obviously, ROI is really fundamentally important to warfighters and to things that as fundamental as security. And so when you think through team selection, it obviously doesn't allow for any room of laziness to say, oh, we want to always have X accreditation because as a baseline, this is a more safe bet. Like, have you seen interesting things across what does it take for the background of the team or the individual? Like, ignore it because it also seems that when we talk to a lot of researchers, it's becoming more prevalent to me that it's not just the world of venture capital where you're betting on the individual early on. Even in research, yes, there's a lot of pedigree and background, but you're also kind of taking about an individual to carry something out. Even if the initial framework is there, the abstract is there, the science is there to support it, it's still a 5, 6, 10, 15, 20-year journey to go carry out these really big missions. So when you think about selecting this team for the first time in really early days, what has been like a unique insight in spotting talent for carrying out difficult scientific tasks?
Yeah, so that's a classic question, right? Is it kind of A team with the B plan or B team with the A plan, right? More or less, right? And so I
Yeah.
think we know the classic answer to that, right? But oftentimes it's not so clear cut. And so I think one distinction I would make is that when I think about selecting teams, right, to work on these programs that we conceive, it's not i- necessarily going to be a 15-year journey that they would have to do, right? So to me, it's we think about metrics, we think about milestones, we think about tempo, and it's really about what's the best team that's going to sort of meet those metrics, right? Because it might be that if we have a technology set that meets these metrics, then that will then catalyze interest from a different
Mm.
stakeholder, right? And so maybe then that they can invest in a completely different team, organized completely differently, right? So just put a little more color on here. So maybe it's an academic team that makes a discovery or has a new insight. Then that can enable a more a mature entity. Perhaps it's a startup, perhaps it's a mid cap that can kind of like leverage that discovery and then kind of kind of operate their part of the value chain that they are optimized to run in, right? And then keep it going, right? So for me, it's really kind of this kind of agreement, then trust, right, with the performer that hey, we think we can get here as in terms of scientists, engineers, can you get there? And they'll say yes. Here's how we can get there. Here's our plan, and we say that looks good. We think we can do that. And so really it's at that level, even though the impact is decades possibly or shorter, right? It's really that kind of like high tempo, high feedback, tight, those tight loops that are happening during the program. So it's really just, like that's the thing, that's the problem in front of us. So that's the problem that we focus on.
Yeah, super fair. And so I want to kind of dive into actual like examples of stuff that has been done at DARPA and just maybe some of the science behind some of it and the thought process at the time and how that impacted the world. One of the things we talked about that I'd love to rehash with you from the first time we spoke was some of this dual use in pharma biotech and the COVID scenario. Just walk us through what that was, what happened, and is that something that COVID catalyzed? Is that now something we're going to see more from DARPA? Did anything happen before that where there was a dual use kind of pharma biotech type engagement? Just give us some background there.
Yeah. So again, I caveat that this is it was before my time. I joined DARPA in 2022. So by then we're well into the sort of the COVID story. But I can kind of share with you what I read from public channels, and I
Yeah,
hope I get this mostly correct.
sure.
My understanding is that there was essentially a small project. We call them seedlings, right? That was started by a program manager, Dan Wattendorf, that was looking at a very foundational question. It's like, can we essentially just, insert an RNA molecule, right, into a host and have protein machinery already in that host make new proteins based on that molecule. So it's a very, again, you can already see it's very fundamental in terms of its scientific question, right? And so my understanding was that was essentially the entire project was just asking that simple question. And this is probably about almost 15 years ago now, perhaps 2011, I think. And so so that was just a question, right? Can we do this? Like, let's see if we can do this, right? And the answer was yes, we can do this. But of course, there's a bunch of other reasons of why some of the initial ideas kind of weren't going to be compatible with that initial discovery, right? So in terms of applications, right? And then what we found is that if you're able to maybe make small amounts of proteins using that same concept, that's actually maybe not so useful in terms of therapeutics, but it's extremely useful in terms of making um, antigens, right? So proteins that can sort of trigger and train the host immune system to recognize certain foreign proteins, right? And so then that was really the foundation for the technology that eventually got led to Moderna's vaccine, right? And so for COVID, right? So I think that's a great, I think, sort of vignette about how you come up with a very foundational question. Can we do this simple thing, the seemingly insignificant technology, sort of like demonstration? Like the answer is yes, but, and there's a bunch of caveats that make it maybe not useful initially as initially thought. But then sometime later, maybe even 5, 10 years later, that insight, that capability that's newly discovered from a DARPA investment is now then leveraged in a as we know a civilian application.
Have there been any case of that since then, or maybe even since you've joined?
Definitely, so I have to think more about exactly what that's going to be, but I would say another more recent example. Again, this is before my time, but a little more contemporary. Is related to neural interfaces. And again, it's the same kind of story where basically you had a program manager, someone like me, Doug Weber, that basically asked the question: can we think about neural interfaces that are integrated with the nervous system in a much more streamlined, much more benign way? And so the the seedling, right, this very small project initially was essentially asking the question: can you decorate a neurovascular stent with electrodes that can pick up signals from the brain? So the idea is that you can access, through the vasculature, parts of the brain in a fairly non-invasive way, right, minimally invasive way. And so the answer turned out to be, of course, yes. Otherwise, we wouldn't be telling the story, right? And so
Yeah.
that led to that project, right? Led to subsequent investment that led to the company called Synchron that now exists, right? And so this is essentially a neural interface company that's looking at these neurovascular stents that are decorated with electrodes that can sort of eavesdrop on local field potentials within the brain. So now it's a kind of a very high valuation and things like that. But again, it's again almost like directly to the private sector, right? So this could help paraplegics, could help um, it can help with all kinds of sort of improvements in quality of life. But if you kind of trace it back, it's really all about that initial kind of like idea, like what if we could do this thing, right? And so again, you can imagine, just to kind of bring back some of the things we talked about before, that you know there's not this vision like, oh, this ceiling is going to turn into this billion-dollar company. It's like, I wonder if we can just do this one thing, right? And so solving the problem of the day, I think, is that that's the way that you can get kind of these kind of nonlinear gains on the back end in ways that you may not even be able to predict initially.
Yeah, I mean, this definitely makes me think about like chipping away at science, which then has all these outcomes. It would be really interesting to host a roundtable to talk about if we think what's going on today in the whole ecosystem, way beyond DARPA, is efficient. Because if we have the greatest scientists working on scientific problems, then we have grants going out to solve health and this and that, and then we have entrepreneurs being paired with it in a super efficient system. I could see it. I guess maybe we are America's the best example of that today, but probably still some inefficiencies we can catch. So I want to talk a little bit about the program, like specific to the one that you're working on now, smart red blood cells. Give us a little bit of the background as to what it is, why it matters, and what was the scientific idea that spurred this program.
Yeah, that's great. So the the program, just as a summary, to summarize what we're trying to do here, is we're essentially trying to accessorize red blood cells with new components, new receptors, new machinery, new logic elements that can essentially improve their function and let red blood cells do things other than just carry oxygen around to tissues in the body and participate in things like clotting, right? So the insight here is that there's, you know, most of the cells in your body right now are actually red blood cells. So about 80% by number are red blood cells. So we have this massive amount of substrate there that we could possibly be engineered. And so what we're asking is really the foundational question here. It's to what extent can we think about engineering red cells to do kind of other things, right? And so the goals of the program itself are actually quite fundamental. We're just asking very basic questions. It's like, can we essentially, you know, add new proteins? Can we put those proteins on the cell surface within the cell, right? And to what extent can those kind of accessorized red cells kind of participate and interact with the host in kind of interesting new ways? So again, just to foot stop a few things, it's foundational, and we're not doing any human subjects. There's no animal research. There's nothing like that. It's a very basic synthetic biology question that we're focusing on right now.
And what was the Hail Mary catechism behind this? Like, what was the why now that unlocks some of the science here?
Yeah, that's right. So I think there's a few things. So there's one insight is that we're getting a lot better just collectively as society at better at manufacturing cells, right? And so you can imagine, you know, there's actually been a few companies both in the EU and the US that have tried to manufacture red cells as replacement, right? So your blood is like the most important kind of asset in terms of combat casualty care and things like this. So it makes sense that people would want to be able to manufacture red cells, which are, you know, one of the most critical parts of blood, right? So the point being, alongside, we've stood up a lot of this manufacturing capability that's that has reduced the cost of making, let's say, the red cells that would go into a unit of blood. Okay, great. So now it's cheaper. Turns out, right, it's still pretty expensive, and it's hard to beat just getting a pint of blood from a donor, right? If you ever donated blood, right, it's actually pretty convenient, it's easy, and it turns out to be pretty cheap, right? So even though we have this big manufacturing insight into making red cells, it's still kind of never going to really, at least in my view, break the cost barrier down to, you know, it's never going to be as cheap as just donated blood. Okay, fine. Then the question that we ask is, okay, but what if that red cell has some other component of it that is just makes it so valuable that of course that you'd want to make you spend the 5 or 10x more to manufacture that red cell, right? So, like, for example, like, what if that red cell can detect bleeding and then turn on machinery to help clotting, right? So then now you have maybe a transfusion into a warfighter with these smart red blood cells, and, you know, if there's trauma or an injury, right, some of those red cells now convert into something that looks like activated platelets. It can then participate in hemostasis, right? So then in that context, right, having that extra machinery then says, okay, it's actually worth investing to manufacture those red cells that have that unique capability, right? Or what if that red cell that's maybe a couple $100 for a unit of blood, but now it has $80,000 worth of a really high value therapeutic inside of it, right? And so now you can imagine, okay, like, it all of a sudden flips the equation around and says, of course you want to manufacture these red cells because you can get all the gains of biomanufacturing kind of within the red cell, right? That you can then deliver to the warfighter, and then you can then, you know, just essentially, you know, make them have a great day versus if they didn't have that asset in them, right? So that's those are, and again, I think maybe just zooming out a little bit, you can kind of see there, you know, some of the, you know, just the facets of what we discussed already, right? So there's a sort of a service member need, right? We always need, you know, innovations in blood. You can see that across all sectors of the DoW and the private sector as well, right? So that's good. You know, new insight, the ability to sort of engineer and manufacture red cells more in a more cost effective way, and then, you know, interesting gains in synthetic biology as well. Being able to position proteins in certain areas and being able to have proteins interact with one another in networks to form logic and other kinds of on-off switches and sensors and actuators all within a cell, right? So that's another kind of technical pillar that I see as enabling to this program. And then, and then lastly, again, we have, again, just good stakeholder engagement. Like, people that we talk to would love the ability to have blood that can uh, participate in hemostasis, or blood that we could freeze, or blood that we could have high value compounds and therapeutics embedded in the cell itself that we can deliver to our fighters, and then just improve outcomes and protect them.
What is like the biggest? I guess there's a pretty big scientific difference, but what's like the landscape of the market today for something like this? Is it EPO or some kind of other blood boosting medication? It seems like it's a pretty different use case. Um, but what's the delta across like today's market and what this could unlock?
So we're focusing primarily on things like hemostasis. I think that's the most important thing. I think warfighter protection is actually, the most valuable kind of, thing to address, right? And so, in that world, I think there's a lot of interesting civilian products based on coagulopathy, right? And so again, these are parts of our exercise. So we look at the regulatory landscape of blood products out there that are focused on coagulopathy, and then we kind of put ours alongside that, and just ask the question, well, like, how is it different? How is it the same? Like, what would the regulatory process be for this product versus existing products, right? And so those are all kind of part of our canvassing exercise that we conduct to spin up the program initially, and then of course we'll revisit those as we have different solution sets that are not only coming becoming more mature, but solution sets that seem to be like working in the way that we think it might be useful for different stakeholders.
Yeah, I mean that's super fair, and obviously useful to benchmark it in some way, and that seems like to be the best way that's possible. Um, I want to shift gears to something that we actually talked about a little bit earlier in this discussion, but it seems so pivotal in both carrying out whether it's the Smart RBC program or the other programs that have been carried out or will be carried out in the future, is talent and talent attraction at DARPA. We talked about talent selection for programs, but now I kind of understand like the attraction and how you guys think about that to attract cutting edge science for people to actually continue and continue the legacy that you and all these others are building at this organization. Obviously, you guys are doing this podcast, so how do you think about this like in a new landscape of media, of talent attraction, of acquisition of these top frontier scientific ideas? I know we talked about this briefly, but like attracting the brightest minds across the world, where maybe in the past it used to be a different pipeline. Now media and maybe more access to capital, and capital being to some extent cheaper, has swayed that in some extent. So how are you guys kind of staying on top of that to remain number one?
Yeah, that's a great point. So I think off the bat here, so a lot of our program managers have PhDs, not everybody, but so we're all PhD level scientists for the most part, and so I think we're already kind of operating at a technical layer that's highly specialized, right? So we work a lot with we build teams to help us look at problem sets, and so we rely a lot on uh, partners and team members that can help scope out problem sets and technology vectors as well. So, back to the program manager side of the house, though, I think this is obviously been the coolest job I've ever had. I could say that without exaggeration. And it's just, and I think one part about this is the mission. And I think that's an exciting aspect that I actually didn't really fully appreciate until I got in the building. And so again, different than just, I guess, money's great, again, private sector, that's all great stuff, but I think what's interesting is that in my role as an academic and my role now, serving a mission that's bigger than yourself is always a very exciting, really exciting and engaging, and just just exciting opportunity, right? So it's hard to put the words, right? So
No, it's
that's
fair.
really cool. So for example, so we work in a building in Arlington, Virginia, and we work side by side with service members. So we'll see people in flight suits and in different kind of fatigues, right, walking around the building, right, often very quickly. Working with 2 stars, with 3-star generals coming in and out of our building. So I think that kind of engagement is amazing. That is I find that to be the ultimate motivation, right? And so that's, and what's interesting is that energy kind of trickles down for all the operational layers in the building, from program managers to our technical assistants to operations and all the other supporting offices as well. So it's just sort of this kind of broad heartbeat of motivation that's really mission focused and really directed at helping our service members. Um,
Yeah.
so that's about part about motivation. In terms of what we do and who we look for, we're always looking for great new program managers to come in with new ideas. So uh I've been here for 3.5 years. I'm actually quite long in the tooth, I think, as program managers go. And so there'll be a time where I will rotate out, and then someone else would come in and not really even just take my spot, but come in and maybe inherit some of my existing programs, but then really bring to bear their lens, you know, their assumptions and their motivations on the way things are going. And maybe there's dramatic differences that can happen. And so oftentimes, uh, when a program manager transitions out and someone inherits a new program, that is a great chance to reevaluate the landscape, right? And so way back, in this conversation, we're talking about how do you kind of get feedback and how do you challenge assumptions. New people is a great way to do that, right? So bringing in smart people that have a different lens, different set of experiences. That is a great way to reevaluate and potentially either expand or cut or reshape or refocus existing programs. And so, again, to your point, that really relies on having a dedicated, energetic, smart, brilliant people. And luckily, we have them now here at the agency, in my office and on my team, and we're always looking to kind of keep that legacy going.
Yeah, I mean that's like that's a super fair point. I mean, I completely align with you on the mission driven, and I think most engineers or just anyone building something themselves, if they can be that close to actual, yeah, whether it's the warfighters, whether it's the people you're building for, or whether it's like being that close to the problem and seeing your own technologies deployed, obviously has that kind of merit. But I guess the reason I even bring this up is not just as a question, but also as like a quote unquote brainstorming session, because I constantly see this, you know, yeah, I actually asked you the quant question, and the AI startup question before was like hey, you've got the youngest and brightest going to work at quant firms because of capital, and AI startups are becoming so hot. So I guess, and the answer was for the audience was like, okay, they'll make their money, and then they'll go to DARPA. But even within that, if the barrier to capital is so low, what is like is mission the main really attractive organism, or is there like something about frontier science and like a mechanism that is hyper efficient and more efficient than a startup can be, that attracts talent because the problems are so hard and difficult? And then like how is that being displayed? Is that doing podcasts and whatever else? I'm trying to understand like the value chain a little bit, because if, yeah, barrier capital is low and I'm a frontier scientist, and today to raise from venture I can raise $20 million without a problem, the capital is solved, it really becomes like a decision point of where do I want to go? Why do I want to go? Well, maybe I'll make more money here versus there. Like strategically, it would make sense to probably centralize some better scientists in DARPA. How do we achieve that? How do we, continue that prosperity as macro changes so much and AI is moving so fast, and
Right.
science is evolving to some extent?
So yeah, there's a few threads I kind of picked up on there. So I'll kind of maybe repeat one. You can kind of give me the heads up if I'm on the right track here. So I think the first thing is, again, let's say the founder perspective. Like, why would I even bother applying to a DARPA program versus just going out to Sand Hill Road and getting my own check, right? And the simple answer is non-dilutive funding, right? So you work with us, you work with the stakeholders, you get involved in sort of the defense industrial base more broadly with different contacts that can not just write the first check, but maybe they'll write the second check or the third check or the fourth check, right? And so from the founder perspective, embracing that ecosystem just holistically, I think DARPA is a great way to do that. And so, put plainly, we don't really have to seek out, people to work on our problem sets. A lot of times people come to, we put our broad agency announcements out there, and that's usually enough to kind of get people excited about the problem sets. Um, The other thing I would say is in terms of now just for talent, right? What's for example, like if you're a talented scientist and why would you join DARPA? I think again, it's good back to the mission. The mission's again, that's something it's 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 hard to understate how awesome that is and how critical it is. And we have a lot of people from the private sector, either start at DARPA, go out and come back, or from the private sector, start there and then come into DARPA because it's driven by the mission. So I think that's the first and foremost thing. The second thing is I think just the diversity of problem sets, right? So I have a portfolio. So we talked about smart red blood cells, but I have a portfolio where we're trying to model E. coli organisms, and then we have other programs on antifungal countermeasures and for host-directed immunity, right? So you can imagine if you're a founder and you go to your board, to your next quarterly, and you're explaining, yeah, I'm working on this company as promised, but I'm also doing these three other things. You probably would
Yeah.
get not a great reaction from the leadership of that board meeting, right? So whereas right at DARPA, that's seen as actually a benefit, right? You get to you should absolutely work on multiple different complex problem sets because that's the way you bring in new ideas, get new stakeholders, and to your point, kind of you evangelize the mission and the brand of DARPA, perhaps, right? So I think you know going a step further, you might even say if someone's working on just a narrowly scoped domain and that's all they work on in terms of the programs, that's almost seen as kind of a, sort of a bug. It's like, why didn't you expand and take the opportunity to learn about this new area? Because maybe, someone's perspective or experiences could have been applied to a different domain. It could have had an outsized impact that was not even explored, right? So I think the ability
Yeah.
to work on diverse problem sets, I think, with resources, right? With working with the best people in terms of the performer base, so I can, basically call up Nobel Prize winners and just email them, and I'll be on the phone with them that afternoon about talking about the coolest new data from their lab, right? So it's that kind of access, the intellectual access that's just like, again, as someone that likes to learn, it's unparalleled.
That's exciting. I love it. I can feel the passion, which so it's exciting.
Yeah.
As kind of a final question here, um, if you're a young and budding scientist or a young and budding entrepreneur, or people in the audience listening that want to be involved with DARPA, what do they need to do today to kind of build those skill sets, build the right platforms, do the right things to be involved and both help American dynamism, but also be involved with DARPA?
Yeah, that's a great question. I'm glad we're ending in this. So the easy button here is called DARPA Connect. So if you just Google DARPA and then Connect, as you might expect that you spell it, you'll be linked to essentially a portal that has all the different ways that the civilian community can start their DARPA journey. So it might be as a performer and learning about programs. It might be as a talented scientist that wants to join as a program manager. It might be as a potential transition partner, right? That benefits from the outcomes of our program. So that's all kind of laid out very plainly, and that's a relatively new resource that's available to the community. And just to repeat, that's DARPA Connect.
I love it. I love it. Check out DARPA Connect. Well, Chris, this was lovely. Thank you so much for hopping on the Silicon Fox podcast. Very,
Awesome.
very excited about a lot of the work that's going on in America and DARPA, and bullish on the future.
Me too. Appreciate it. Thanks, Mitchell.